So next we are going to see another important problem. Example 6.5. Prove by vector method that sin alpha minus beta equal to sin alpha cos beta minus cos alpha sin beta. So this is the problem we are going to discuss. Previously we have discussed the problem cos of alpha plus beta. Okay, there alpha plus beta. Here we are going to solve alpha minus beta. So it will differ in certain aspects. And the formula cos we have to use dot product, and the formula in sin we have to use cross product. That is the major difference in these two problems. But the procedure is same, the diagram and all those things are same. Okay. So first we have to consider a unit circle. So this is x and y axis. I am going to consider a unit circle with the center O. So we are going to consider a unit circle with the center O, and you have to select 2 points on the circle. So this point is A, and you have to take another point as B. So if the problem is alpha plus beta, means you have to take the first point in the first quadrant and other point in the fourth quadrant. But if your problem is alpha minus beta, you have to take the 2 points in the first quadrant. So that if you join those points, that OA, it makes an angle alpha with the positive x-axis, and similarly if you join the line OB, it makes an angle beta with the positive x-axis. Okay, so the angle between A and B is alpha minus beta. And the next thing what I am going to do is I am going to make a construction that you have to draw a perpendicular line AM, okay, which is perpendicular to x-axis, and also from B you have to draw a perpendicular line. This we can take it as L, and this point we can take it as M. Okay. Next you have to write the coordinates. Here the coordinates is cos alpha comma sin alpha, and here the coordinates is cos beta comma sin beta. This distance, the distance OA can be taken as, and this vector can be taken as A cap, and this vector OB vector can be taken as B cap. This is the thing you have to furnish in the diagram. Okay, ma? Next I am going to write the statements. So what is the first statement we are having? Let us consider a unit circle. Let us consider a unit circle with the center. With center O. Okay, unit circle means whose radius is 1. As I have mentioned earlier, you have to consider the unit circle. Okay, next what I am going to consider is, let us consider a unit circle with the center O. Next, the line OA and OB makes an angle alpha and beta with the positive x-axis. So the lines OA and OB makes angles alpha and beta with positive x-axis. And one more thing what we are going to do is, with the positive x-axis alpha and beta, it makes an angle. Then we have to write that the distance OA equal to the distance OB equal to 1, because they are all radii of the unit circle. Next thing what we are going to do is, we are going to declare that let I cap, comma j cap and k cap are the unit vectors, along x, comma y and z axis. X, y and z axis. So along x axis I am declaring I cap, along y axis I am declaring j cap, and in z axis you are having the vector that is k cap. Okay. So now we are going to write the vector. First we are going to write the vector OA vector. So OA vector, we can write the vector. Starting point is O and ending point is A. How to go? First you have to go to L, then you have to go to A. So OA vector is equal to OL vector plus LA vector. OL vector plus LA vector. So OA vector is equal to OL vector plus LA vector. So OA vector can be taken as A cap and OL vector. First you have to write the magnitude or length of the OL vector. First one is the length of the OL vector. So I have to write the length as cos alpha, and in that vector you are having corresponding unit vector I cap. You have to multiply that I cap. Okay. So the corresponding vector in the direction of OL vector is I cap. So you have to multiply that cos alpha into I cap plus LA vector. The magnitude or length of LA vector is sin alpha. Okay. So this is sin alpha into next, the direction of LA vector is in above direction. Here you are having the unit vector in that direction is j cap. So sin alpha into j cap. This is the thing. Next we are going to write the OB vector. So OB vector is equal to starting point is O and ending point is B. So which can be written as OM vector plus MB vector. OM plus MB. So this can be written as OM vector plus MB vector. So OB vector can be taken as B cap. OM vector, the magnitude or length of OM vector is cos beta into corresponding unit vector in that direction is I cap plus MB vector. MB vector direction, it is in above direction. Okay. So in that direction you are having the unit vector as j cap. And the length of that is sin beta. So you are having sin beta into j cap. So we have found out cos beta into I cap plus sin beta into j cap. Next thing, we have to make use of cross product for the formulas related to sin. Okay. So now by definition of cross product. So you have to take cross product in only in this order. That is, you have to take the below vector, then you have to take the above vector. So we will B cap cross A cap equal to modulus of B cap modulus of A cap into sine of the angle is alpha minus beta. The unit vector perpendicular to both I cap and J cap is K cap. Okay. Next thing what we are going to write is from which you can get that B cap cross A cap is equal to this is 1 and this is also 1 because they are all the radii of the unit circle. So you will be left with only sin alpha minus beta into K cap. Okay. So this is the thing. You have to take this as first one. Next, by finding the value of the cross product. How will you find the value of the cross product? Means you can find by using the determinant method. What is the determinant method? I cap, J cap, K cap. The first vector you are having is B cap. You have to write the terms. Okay. In B cap, the first number is cos beta and second number is sin beta. Okay. So first cos beta, next sin beta, next there is no K cap, so the coefficient is 0. The term is 0. Next A cap. In A cap you are having cos alpha, sin alpha. There is no K cap term, so it is 0. Okay. So you will have cos alpha, sin alpha, then 0. You have to expand this alternating plus minus plus. So when you are expand this, you will get that I cap into what you will get. Both the things are 0. So 0 minus J cap into this is also 0 plus K cap into you have to multiply. So you are multiplying this sin alpha cos beta minus cos alpha sin beta. So sin alpha cos beta minus cos alpha sin beta. This is the thing you are having. So when you are simplifying this, B cap cross A cap is equal to K cap into what you will have? Sin alpha cos beta minus cos alpha sin beta. Okay. So this you have to take this as equation number 2. This is equation number 2. Next what we are going to do is we are going to compare the equations 1 and 2. When you are comparing the equation 1 and 2, the left hand side are equal, so the right sides are going to be equal. From 1 and 2, From 1 and 2 we have the left sides are equal, so the right sides are going to be equal. So you will have k cap into sin alpha minus beta is equal to k cap into sin alpha cos beta minus cos alpha sin beta. Okay. So next we have to cancel this k cap. Since it is a unit vector, when you are taking modulus, the unit vector get cancels. So you have to take in modulus. So when you are taking modulus, k cap will get cancels. So you will have that sin of alpha minus beta, which is equal to sin alpha cos beta minus cos alpha sin beta. Okay. So this is the thing we are in need to prove. I have proved that one. Okay.